Good morning. Today I'm going to be filming module 12.4 and this is measures of spread. So let's go ahead and look at our learning target. I can determine the measures of spread including the range and interquartile range of a set of data. Determine the standard deviation of a data set. So most of this we have done in the past. The only thing which is going to be new is standard deviation. Note, standard deviation is different from mean absolute deviation, and we will talk about that in a minute. Okay, so let's go ahead and talk about what is range and what are the measures of spread that we are talking about. You know, statisticians use measures of spread or variation to describe how widely data values vary. And one such measure is the range. Okay, the range. And what is range exactly? It is the difference between the greatest and the least values in a data set. Okay, so greatest value minus the least value in the data spread, in the set of data is going to give me range. So that just tells me the spread of the data from where to where are the data spread out. So I always take the greatest value and I subtract the smallest value from that, and that is what range is. Okay, now let's talk about the next thing, and that is my interquartile range. So normally we have a thing called the 5-number summary. Okay, the 5-number summary. Okay, and we use this to find out how to plot a box and whisker plot. And in a box and whisker plot, basically the 5-number summary means I need the smallest number in the data set. I need the largest number in the data set. Okay, I need to know the median. I need to know the first quartile, which is also called the lower quartile, and I need to know the third quartile, which is also called the upper quartile. Remember, median is the second quartile. And so these are the 5 numbers that are required to plot a box and whisker plot. And the reason we're talking about measures of spread is that we are basically looking at what is the spread of the data between the first and the third quartile. So that is called the interquartile range, also known as IQR. And IQR is nothing but third quartile minus the first quartile. And this will give me the range of data within the box part of the box and whisker plot. Okay, so this is a quick review of everything again that we've done since 6th grade. And so this is what the 5-number summary is. Quartiles divide a data set arranged in ascending order into 4 different groups. And we know that each group has 25% or 1/4 of the data in there. And a 5-number summary contains the minimum quartiles. The maximum of a data set contains, so once again, the smallest number, the minimum, the largest, that is the greatest, median, which is the second quartile, and we have the first and the third quartile. So this is my 5-number summary. So what is the median mark? The median marks the second quartile. Okay, and so this is nothing but Q2, which is my second quartile. And what is it doing? It is separating the data into the lower and the upper half. So it's the halfway point. And that's what the median is. Remember, the first step is always to put the data from smallest to the largest. We can't have it in any order, okay? It's got to be smallest to the largest, and then that'll tell us what the middle number is, which is the median. The lower quartile is the median of the lower half, and the upper quartile is the median of the upper half. So everything, as you can see, half and then half of half on both sides. That means each section contains 25% of the data, okay? So, a box plot or box and whisker plot is a graphical representation of the 5-number summary of a data set. And I'm going to take you, just so that you can see it, just to refresh your memory. And here we go. So look. So this is a 5-number summary of a data set. A box is drawn from Q1 to Q3. And so I can just look at this box plot and know where the median is, what the first quartile is, what the third quartile is. So look, this is my first quartile and this is 10. So my first quartile, okay, is going to be 10. My third quartile, which is Q3, is 26. Just by looking at this, I can see that, okay? And then, what is my interquartile range? My IQR is whatever is within the box. So it is Q3 minus Q1. And in this case, I can see it is 26 minus 10. And that gives me how much? 16. So this is my IQR, okay, which is the difference between the upper and lower quartiles. The whiskers of the box plot are drawn from Q1 to the minimum number, and you can see that the minimum number here is 5. The largest number is 30, and I can see that this is my median here, okay, and I can see that my median is 22. Okay, this is my median. That is my Q2, median also called Q2. And we know that within each part, how much data is it holding? 25%, 25%, 25%, and 25%, or 1/4. Each section has 25% of the data in there. Okay, so we are now going to go ahead and look at the range of the scores. So let's start with that first. So I have this data set provided to me, and now what I need to do is find the range, okay? So in order to find the range of the scores, we are going to arrange the data in ascending order. In ascending order. And that basically means from the smallest to the largest. Okay, smallest to the largest. And so I have smallest is, and first obviously always do this. 1, 2, 3, 4, 5, 6, 7. So then therefore when I have my final numbers written in ascending order, I don't make a mistake, okay? So I have 62, then I have 70, then I have my 79, 83, I'm just putting them in the correct order. And then I have 88, 91, 99. Now let's see. 1, 2, 3, 4, 5, 6, 7. All right, I have all 7 data pieces over here. Then we are going to determine the range. And I said range was the largest value or the greatest value minus the least value. What is my greatest value here? It's 99. What's my least value here? It's 62. So all I'm doing is range is going to be my greatest, which is 99, minus my least, which is 62. And so I get my range as 37. And this is the spread of the data over here that I have. All right, so I have been given a data set over here, and I am going to make a box plot with this. So let me try to bring this a little closer so you can see better. All right, so here we go. So we're going to make a box plot with this data. So and we're going to do the 5-number summary first. So my first step is to arrange the data in ascending order. That means from smallest to the largest. I can see my smallest number is 1215. So I'm going to start putting it in the correct order. So 1215, once again, ascending order. I'm going to just write that here so you remember. Ascending order. And that's the first step. Okay, always. So we have 1215, we have 1277. Okay, we have 1342. So literally, like, it is kind of already in the correct order. I'm just writing it backwards based on how this is. But yeah, so we've just got to put it in the correct order. 1405, 1516, 1520, 1670, 2060, 2187, and 2788. Okay, so these are the values. So we have 2, 4, 6, 8, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is the first step we always need to do, is put it in the correct order. Now we are going to do the 5-number summary of the data. So first thing, this is my minimum. This is my minimum. Okay, and this one here is my maximum. So these are the 2 points. Okay, now since I have 10 numbers in the data set, I know I'm going to have 2 numbers in the middle. And if I get 2 numbers in the middle, I need to find the mean of the middle 2 numbers, right? So since it's 10, we are going to have 1, 2, 3, 4, and we're going to bring here 1, 2, 3, 4, bring it here. So we're going to look at these 2, and what is in the middle of 15, 16, and 1520, we are going to take that and average it out, and I get 1518. I mean, if you think of it, 16 and 20, this is going to be 1518. So this is my median, okay, which is my Q2. Then I'm going to look at the lower half. So 1, 2, 1, 2. So this is my middle. So this is my Q, my first quartile. And then same thing up here. 1, 2, 1, 2. This is my third quartile, my Q3. Okay? So now, once I have got this organized, I've got my 5-number summary, I am going to construct a number line. So to make my box plot, I need to know, obviously, that my smallest number here is 1215 and my greatest number here is 2788. So I'm going to make a number line. That's what I'm going to start with, and I should have my least and my greatest in there. So I'm going to start with 1200, and then I'm going to go in hundreds so that everything fits in here. So 12, 13, 14, 15, 16, 17, 18, 19, 2000, 2100, 2200, 2300, 2400, 2500, 26, 27, 28, and this is going to be 2900. So it should include the smallest and the largest in there. Okay, so I've gone in increments of hundreds over here to my intervals. Okay, so now I am going to go look at what is my median. My median is 1518. So that will be somewhere about here. So I'm going to make a dot. Then I have my first quartile is at 1342. which will be somewhere over here. So I am going to make a dot over here. Then I have my third quartile at 2060. So that should be somewhere here. And I am going to do this. Once I have my 3 dots, I am going to make a box around. Okay, I'm going to make a box. And then I'm going to draw the line down to show that that's the median. And then I'm going to make the whiskers. The maximum is 2788. So this will be somewhere here. So I'm going to do this and I am going to pull this here. Okay? And the minimum is 1215. So which will be somewhere here. So I am somewhere here, and I am going to do this. So now I have my 5 points all plotted over here. And that's how I make a box and whisker plot. This is telling me the minimum. This is telling me the first quartile, the second quartile, which is the median, third quartile, and I have my maximum. Okay, so now what I'm going to go ahead and do is, if I am trying to find what is the interquartile range, all I need to do is I look at the third quartile, which is 2060, minus the first quartile, which is 1342. And I would get 718. And that would tell me my spread of the data in here, if I was trying to find interquartile range. But right now I was just trying to show you how to make a box plot using my 5 numbers that are required for this, okay, which would be the 5-number summary. All right, let's look at this word problem, and now we are trying to find the interquartile range. Audio. Sarah wants to upload a song that she recorded and share it with her friends. She wants to know whether her song, which is currently -12 decibels on average, is the right volume compared to other songs online, so listeners do not have to adjust their volume. She writes down the average volume of 7 songs. Find the interquartile range of these average volumes. So here's the data that is provided. Now, what is the first step? To organize it from the least to the greatest. So we're trying to put it in ascending order. Now, since these are negative, please remember that it goes in the opposite direction. The larger the number looks, it's actually smaller. Okay, so let's not forget how it's reflected on the negative side of 0, after on the left of 0, what happens to those numbers, okay? So we are ordering the data from the least to the greatest. I have 1, 2, 3, 4, 5, 6, 7. So let's go ahead and organize. And so my least number here I can see is -20. Okay. Then I have 2 -18s. You're going to write down both the numbers. Do not skip. Then I have -15, -14, and then I have -13. I have -8. So let's see. 1, 2, 3, 4, 5, 6, 7. There we go. Next, I'm going to determine the Q1 and Q3. Now, sure, in a box and whisker plot, I need the 5-number summary. But for the interquartile range, all I need is the third quartile and the first quartile. And of course, I will have to find the median first. So, if I look at this, so I have 7. So that means 3 on this side, 3 on this side. This is my median. This is my median. Right? So this is my median. Then I'm going to look at the lower half. So if I look at this here, this is my first quartile. This is my third quartile. This is my Q3. And of course, my median is called my Q2. Right? And so the next thing I am going to do is my IQR is Q3 minus Q1. Okay, so I am going to do, what is my Q3 is negative 13 minus, what is my Q1 is negative 18. And so this becomes negative 13 and we are adding the opposite, so plus 18. And then what is 18 minus 13? I get 5. So 5 is my interquartile range. 5 is my interquartile range, and that's it. Simple as that. Again, this is just a review of what we've done in 6th grade. Okay, so last thing I would like to focus on is standard deviation. All right, the last thing we're going to do is talk about standard deviation. And I just want you to remember that standard deviation and mean absolute deviation are two different things. Now, we have done MAD, which is mean absolute deviation, in 6th grade and in 7th grade. And we know in that what we do is we calculate the mean, and then we see the absolute value or the distance of a variation from that mean. How far has it deviated? So we see how far a number is from the mean. Now, when we actually do absolute value, we are talking about how far is a number from 0 on the number line, right? But when we do mean absolute deviation, we are trying to see how far is a number from the mean. And then we take all those the distance of each of the data points from the mean, and then we find the average of that to see what is the variance, okay? But what is the variation? But in this case, look at standard deviation formula. What we're doing over here, standard deviation and mean absolute deviation again are different measures of variability. They are calculated differently. Standard deviation, it uses the square of the deviations from the mean, while mean absolute deviation uses the absolute value of the deviations. So let us look at this, and hold on, I'm trying to make sure that you can see. There we go. That is better. Okay, so here we go. In a data set, the standard deviation shows how the data deviate from the mean. A majority of the data in a set, approximately 2/3, is contained within one standard deviation below and above the mean. So if two data sets have the same mean, but one has a greater standard deviation, then the data in that set is more spread out from the mean. So we're just trying to see how far is it from the mean, and that's what standard deviation is. Okay, now this is the formula that we have for standard deviation, and first we do is we find the mean, and that is represented by mu. It's a Greek letter, mu, which is pronounced, of course, like M-E-W, mewing, mu. Okay, so and it's commonly used in statistics to represent the population mean or average. So we find the mean, again represented by mu. Okay, the next step is we find the square of the difference between each data value, x sub n and the mean. So look, we are finding the square of the difference. So this is how far this one is, this is how far this one is, and we are squaring it. And then what we're doing is we are finding the sum of all the values in step 2, all that. We're going to add it up, and we're going to divide the sum by the number of values in the set of data, n, and then this value is the variance. So formula, and we call this letter sigma, and this is representing our standard deviation. Okay, so once again, the lowercase sigma is used to represent the standard deviation of a population, which measures the spread or dispersion of data points around the population. So let's use this knowledge to calculate a problem. Okay, so I am just going to do it on the whiteboard. All right, so I have this data provided to me, and I am going to try to find the standard deviation of these numbers. So I can see I have 1, 2, 3, 4, 5, 6, 7 of them. So the first thing is I'm going to find the mean. Okay, so I'm going to find the mean, and which is represented by mu, right? So I'm going to take 27,300 plus 12,333 plus 15,570 plus 21,610 plus 17,413 plus 25,772 plus 18,230. And I'm going to take the sum of all of this to find the mean. I add all the data and I divide by 1, 2, 3, 4, 5, 6, 7 by 7. Okay, so when I use my calculator, I am going to get, this is equal to 19,747. 19,747, and this is my mean. Okay, so that's the first thing I need to do. The next thing I'm going to do is I'm going to find the square of the differences. Square of the differences. So I've already written this down. I'm just going to add on 1. So all in the front, what is my mean? It is 19,747. And so square of the differences, that means I take this squared. Okay, so for all of them, I'm doing the same thing. 747 minus this squared. 19,747 minus this number squared. So I am trying to find the square of the differences. Minus this squared. And so continued, we take that mean that we just calculated and I subtract each of this. Okay, and then I square it. So 19,747 minus this. So this is my first step after finding the mean. Okay, because I'm trying to find the square of the differences, which is what? This part. I am doing my mu minus x of n squared. That's the part that I am working on. Okay, so once I do this, I'm going to use my calculator and I get these numbers. 57,047,809. Okay, that's for the first one. And then I'm going to carry on and I'm just going to write this down just to save us time on the filming. So I've just put all the numbers here. I have just found the square of the differences. So once again, look what I did. Okay, so I found the square of the differences. Next, what I'm going to do is I am going to add all this up. And when I add all this up, I get, so on adding all of this up, this much, I end up with 176,982,773. And then I take this value and I divide by 1, 2, 3, 4, 5, 6, 7 by 7. Okay, and so I get approximately over here 25,283. 200. Okay, so 25,283,253. So this is what I get. And then the last thing, I need to do the square root of this because this is all within this, the square root. And I get approximately 5,028. So here is my standard deviation. Okay, so that's how we calculate standard deviation. Don't look at the formula and get stressed out. It's not a big deal. You just take all the values that you are given in the data set and you first find the mean. And we've done mean since 6th grade. Add up all the numbers and divide by how many numbers there are in that set. And so once I've calculated the mean, I am going to subtract each of the values from the mean and I'm going to square it. So that is what, see, all the mean is on the left and I'm subtracting each of the values provided to me in the data set, and after subtracting, I square that. And then whatever value I get, it's like, again, I am finding the mean of that. So I'm adding it all up, which is the variation over here, how far it is deviating from the mean. I'm going to add them all up, divide by how many there are. So in this case, there was 7. And then I just square root it. And when I square root it and I'm using a calculator, this is what I get. And that's how I calculate my standard deviation. Okay, so yeah, don't look at the formula, get stressed out. It's not a big deal. All you're doing is subtracting from the mean and squaring it and then doing the square root of that. Okay, so measures of spread, once again, for us to know the spread of the data, how far it is, between which numbers is the spread, we can use a range. In range, we're taking the largest minus the smallest number in the data set. We can use interquartile range, so we've got to know our the 5 numbers that are required to create a box and whisker plot. And of course, we have the smallest number, largest number. We have the first quartile, second quartile, which is the median, and the third quartile. And for interquartile, and I also showed you how to construct a box plot. And for interquartile range, I just take the first quartile and I subtract it from the third quartile to get the interquartile range. And then for standard deviation, once again, I am taking, finding the mean first. And from the mean, I'm subtracting each of the values and I'm squaring it. And then I add up all those values at the end and I divide by how many data points they are. And then in the final answer, I just square root the whole thing. And that gives me my standard deviation. And that concludes our module 12.4. Have a great day, everyone.